There are a few more issues that come up in spelling correction that we want to include in any kind of state-of-the-art system. One is HCI issues, human-computer interaction issues. So if we're very confident in a correction, for example, we might want to autocorrect. And so that happens very often, as I talked about earlier, with the example HTE, which is a very common misspelling of THE. If we're slightly less confident, we might want to give a single best correction, but to the user to say yes or no to. If we're even less confident, we might want to give the user a whole list and let them pick from this list. And if we're just unconfident at all, but we're pretty sure we saw an error, we just don't know how to fix it, then we might just flag what the user typed as an error. So various things, again, depending on our application and depending on the probability and the confidence value that we might generate. In practice, for almost all noisy channel models, even though we define the model as multiplying a prior and a likelihood and an error model, in practice, these two probabilities are computed from making a lot of different independence assumptions about how many errors there were and the fact that the spelling is independent of neighboring words, and these are really not true. And the result of these incorrect independence assumptions means that these two probabilities are often not commensurate. So what we do, in fact, is instead of just multiplying these two, we weight them. And the way, since we're multiplying probabilities, we weight them by raising one of them to a power. We can't obviously multiply one of them by something. So we weight them by raising one of them to a power, lambda, and we learn this lambda from some development test set. We pick whatever lambda to raise the language model probability to, such that the product is more likely to pick out just those errors that really are errors. And we use this weighting of the noisy channel model in almost any application that we see of the noisy channel model. Something else that's used in state-of-the-art systems is to use not just the spelling but the pronunciation of the word to help us find errors. So the Metaphone system, which is used in GNU ASpell, instead of just asking for candidates that have a similar spelling, ask for candidates that have a similar pronunciation. And that's done by first converting the misspelling to a pronunciation, and the Metaphone is a simplified pronunciation system, that a set of rules that convert a word into something approximating a pronunciation. And here's a kind of rules that get used. Drop duplicate adjacent letters except for C. If the word begins with KN or GN, drop that first letter. Drop B if it's after an M, and if it's at the end of the word, and so on. So these are dropping various silent letters. And various rules like this convert the misspelling into a kind of representation of the pronunciation, has a single vowel at the beginning and then a set of consonants. And then we find words whose pronunciation is nearby the misspelling's pronunciation, so we've converted all other words into the Metaphone pronunciation, find similar words, and now we score the words by some combination of two edit distances. How likely is the candidate to be orthographically changed into the misspelling? So we'll use some kind of channel model-like thing. And the same thing with the pronunciation. How likely is the misspelling to be pronounced like the candidate? So a Metaphone system doesn't use a language model, but uses a pronunciation-based kind of channel model. And you can imagine also combining a pronunciation-based model with a noisy channel model. And modern models of the channel in the last decade or so allow a number of kind of improvements like this. So incorporating a pronunciation component into the channel model is one. And we also might want to allow richer edits. So not just single letter edits, but kind of edits like a PH being incorrectly typed as an F, or very common error. It's not that all E's are mistakenly typed as A's, but that the sequence ENT is very likely to be mistyped as ANT. So a couple of different improvements that a state-of-the-art system might have in the channel model. And in fact, we could consider a very large number of factors that could influence the probability of a misspelling given the word, the channel model. So we've talked about the source letter or the target letter, and we talked about, maybe one surrounding letter, but we could look at more surrounding letters, or we could look at the position in the word. Maybe some errors happen in the middle of the word, some happen at the end. We might explicitly model the keyboard and talk about nearby keys on the keyboard, or homology. We're likely to mistype a word with our left hand third finger by using our right hand third finger. So a key which is on the same finger on the alternate hand is homologous. Or again, we might use pronunciations. We might use these kind of likely morpheme transformations we talked about in the last slide. Lots of possible factors that could influence this channel model. Here's a picture of one of them, the keyboard. So again, we might want to say that R and W are likely mistypings for E, and so on, if we're on some kind of a phone keyboard. So combining all these different factors is often done with a classifier-based model. So the classifier-based model is an alternative way of doing real-word spelling correction. And here, we instead of just two models, a channel model and a language model, we might take those two and a number of other models and combine them in a big classifier. We'll talk about classifiers in the next lecture. And so, for example, if we had a specific pair like weather and weather commonly confused real word confusions, we might look at features like, well, is the word cloudy in a window of plus or minus 10 words? Or am I followed by the word to and then some verb? So if the word cloudy is nearby me, I'm probably the word W-E-A-T-H-E-R. If I'm followed by to verb, I'm probably the word W-H-E-T-H-E-R. So whether to go, whether to say, whether to do is probably this weather. Similarly, if I'm followed by or not, then I'm probably this weather. So each of these features, plus the language model, plus the channel model, could be combined into one classifier that could make a decision, and we might build separate classifiers for each possible likely pair of words. So in summary, real-word spelling correction can be done with the same noisy channel algorithm that's used for non-word spelling correction, but we can also use a classifier-based approach where we combine a lot of features and build classifiers for very frequent kinds of errors we like to model explicitly.